This is Leetcode 53, the maximum subarray. This is one of the most famous Leetcode questions, and it has 33k likes. So we are given an array nums, and we need to find the subarray with the largest sum. For example, we are given this array, and the largest sum is this subarray. Next, I'm going to talk about how to solve this question. Because the number's length is quite large, 10 to the power of 5, the brute force approach, which takes O(n) square time, it won't solve this question efficiently. So I'm going to talk about the Kadane's algorithm and dynamic programming, which takes O(n) time. This algorithm is about making the decision. Suppose we have the I here, we need to make the decision if we add these numbers i's to the previous subarray, or we replace the previous subarray with the numbers I. So we have to compare those two. -2 plus 1 plus -3, it's -4, and then it's -3. So the best solution is we only keep -3. And this is the Python code. First, we're going to define the subarray and the max result. It's the first element. And then while we are accumulating the sum of the subarray, we compare the existing nums I with the subarray, and then we need to make this decision. So if the nums I is greater than the sum sub, then we replace the sum sub with the numbers I. Finally, we get the maximum of the sum sub and the max result, and we return the max result. If we implement this in a DP approach, then we need to have a tree because we are doing it in a recursive way. You may think this is going to take n log n time, but that's actually not the case. It's O(n) because we are doing the same calculation twice and so on. So we have a repeated calculation. We can use the cache in Python to bring this time complexity to O(n). Let's implement this in Python. First, we're going to come up with the base case. If the must be is true, then we return 0. Otherwise, we return the smallest amount integer. Here is the return statement. If this is true, then we need to add the current nums to the previous accumulation. Otherwise, we keep moving to the next DP.